rememberized. The opposite of b plus or minus squared would be b squared minus 4ac all over 2a. Okay, so let's do some examples using the thing. How's that sound? Grand and glorious? It's not so bad. Could be worse. So what are So what are y'all gonna do tomorrow morning since you don't have to go to Grace? You're gonna sleep in and then go shopping. Drive to Amarillo with your dad. You have a dad? What? Oh, I guess everybody does.
I'm just gonna sleep in, unless work decides I should work tomorrow, which I don't think they will. They would let me know by now if they were gonna.
We're gonna solve x squared minus 10x equals 11 with the quadratic formula. Okay. So, there's two things we need to know in order to use the quadratic formula. We need to know the formula, and we need to know ABC, right? So in order to know ABC, first of all, we got to get this equation in standard form, which it is not in. So in order to get this in standard form, what do we need to do? We do need a 0 on that side, so how can we get that to happen? Minus 11. Brilliant. I agree. Now subtract 11 on both sides. And then we end up with x squared minus 10x minus 11 equals 0. So now that we have that, excuse me, now that we have that in standard form, we can write what A, B, and C are, right? So in this particular problem, what is A? 1. A is 1, that's right. How did you know that? It's the number in front of the x squared, right? Not the one for the x, right? What is B in this problem? 10. Close, but no cigar. Negative 10, that's right. Which I guess is good, because we don't want a cigar, right? Smoking is bad. It is definitely unhealthy for you. I'll say that much for sure. What's C on this problem?
Not the best for your trachea either.
Negative 11. Or your wallet. Now, what's the quadratic formula?
It's great for the cancerous cells forming in your mouth, though.
You don't it's not impossible, but you don't typically get cancer in your mouth from smoking cigars, although you can. Typically more your lungs. What's the formula? You should have it in your notes. Quadratic formula. What is the formula?
b plus or minus the square root of b squared minus 4ac all over 2a.
Yep, that's what it is. Which again, for the third time at this point, is one that you will have to memorize. If you look around on the YouTubes, you can find a method of memorizing that by putting it to the tune of Pop Goes the Weasel. I'm not going to sing it for you, even though I'm sure you would enjoy that. Not because it was going to be quality, but because it would be funny. But if you look around on YouTube, I will guarantee you can find that. So,
hey, at least it would be better than the Beatles.
Better than the Beatles. You're gonna keep punching that silliness, huh?
Yes.
I don't care if you don't like the Beatles. That's fine. That's totally reasonable. Your statement that they are objectively bad is foolish on its face, though, and unprovable. Okay. So now we're just going to write the formula with holes everywhere the variables live.
Yes, the variable should live in a little hole, dark and cold and damp.
And then we're going to take and stick numbers where they belong. So what number is going to go right here?
Negative 10.
-10. And here, -10. Whoop. Hello.
Negative 10.
And then here, we're going to put a 1. And here, we're going to put a -11. And here, we're going to put a 1, right? And then we're going to simplify this from the inside out.
What about side in?
No, inside out. Always inside out. Okay, so
Like that movie
I like...
from 2017.
Never seen it. But maybe. So I like to start by doing this little squared and then this little multiplication first, because those are pretty easy to go ahead and do in one step, right? So that's, and potentially do something with this if we have to do, it's either going to be negative or positive. So those are the things that I like to do on step 1. If you want to break it down in smaller bits, that's fine too. So -10 is what? Or the opposite of -10 is maybe an easier way to say it. Positive 10, right? So we've got 10 plus or minus the square root of what's -10 squared?
Negative 100.
It's a good guess, but no.
No, negative 1,000.
Also not quite right.
Okay, I don't know that I'm bad at math.
You So remember that we're squaring the negative too. So it's -10 times -10, and negative times the negative is positive, so it's positive 100.
Oh, yeah. We're all bad at math.
Well, all the ones with the male persuasion, maybe, at least the ones that have spoken anyway in the last few minutes.
Oh, he's fine.
Oh, too late. Oh, he ruined it. Now he's bad at math.
I'm fine with that.
It's false, but it's okay. -4 times 1 times -11 is what? -4 times 1 times -11 is what?
Negative 44.
So close. Positive 44. Because we've got negative times positive times negative. So negative times negative is positive. Yes? So plus 44. All over 2 times 1, which is what?
No,
Y'all have got to be asleep because I keep asking easy questions and then there's no response on the easy stuff. So next, we of course would add these two together, right?
No. That's magic, man. You can't do that.
You can do that. X equals 10 plus or minus the square root of 144 over 2. It would be 12, which if that comes out even, it means we could have ultimately, if we weren't told how to solve this one, we could have saved some time and factored this from the beginning, but that's okay. Because it's easiest to learn these by starting with whole number stuffs. So, X equals... You okay?
Just put the over 2, 2, the divide by 2 both numbers, or is that?
Yeah, well, and yeah. We're going to split it and actually find the number answers because we got a whole number. So we can do that, right? So since we can, we have to, right? That's kind of how it works with simplifying things. So we're going to split this into 10 plus 12 over 2 and 10 minus 12 over 2, right? Ten plus 12 is 22. And 10 minus 12 is negative 2, right? So our answers are x equals 11 and -1. Oh,
They froze and then did it all over.
so magical. How do you know I just didn't do it? Maybe I'm magical. Makes sense to everybody. Any questions on this particular problem?
Why was it so much easier than the other ones we did last week?
Maybe because this method makes more sense. I don't know.
Okay. Yeah, I guess so. Because last week we had all these fractions and stuff, and this time it was just
Don't
pretty
say that.
simple.
It is
Well, I mean,
It is not uncommon for students to really like solving quadratics with the quadratic formula. In fact, it's not uncommon for students to, even though it is faster and easier to just factor a problem like this, to still solve it with the quadratic formula because they're like, okay, I understand this. And this is step by step, and I don't hardly have to think because I already took the time to memorize the thing, so I'm just going to solve everything like this. So that is not uncommon. I would encourage you to hang on to factoring for two reasons. One, because there will be problems on the TSI since it's a multiple choice test where you'll kind of have to be able to identify the factored bits and all that kind of stuff to be able to answer that question correctly. Number two is because later on, if you take trigonometry or precalculus or whatever else, then when you have to factor something with sine and cosine in it, you can do it easier. You need to get some water?
No.
Are you sure?
Allergies.
Well, I believe that. That doesn't mean you don't need some water. So,
the chances are I'll take trigonometry or calculus in college are very low.
it's very possible.
Maybe.
You're thinking something English related or theater related or something?
Related
Theater related. You want to be a theater teacher or you want to
teacher.
go to Juilliard?
Oh no, I don't have that kind of skill or dedication, but I could be.
Dedication is the key word there. Because
Well,
skill is very relative, especially in context. We're going to do a GP number 1.
Although the guy who voiced Hey Hey in Moana has only ever voiced animals, and he went to Juilliard, so there's that.
Was that, what's his face? The guy that's done lots and lots, what's that guy's name?
I can't remember. He looks like the kind of guy who would go to Juilliard and end up on
There's a guy that has done so many voices of like,
He's voiced
creatures.
pretty much every animal that Disney's ever put out, if I remember right.
well, the person I'm thinking of is not even mostly done Disney, but so I may be a different person.
GPO.
I can't. Yeah. Example then GP. That's kind of how we roll around here.
Or example, then GP.
Sometimes.
If it's a
Sometimes. It kind of depends. Ready, go. Solve for x using the quadratic formula.
Yeah, Alan Tudyk. The guy who voiced all the...
So, there's where you ought to end up.
What if I had the fraction first?
I did skip a couple steps, so if I need to go back and fill in any bits, let me know.
264.
4 times 2 times 33.
-4 times
Yes, yes, which is why it's minus.
But I think from my quadratic formula, that's why you don't write it out.
If I put the -3/2 first, is that fine?
That's totally fine.
Great.
I can see how it would have gone.
What if I didn't, but what if I put it to 1 and 1/2?
That's also fine.
Okay,
1.5 would also be fine.
cool.
But kind of a waste of time at some point.
Yep.
At some point, just the reduced improper fraction is your best bet. Because it takes you less time and there's less chance for accidentally making a weird mistake at the very end because you were trying to do an extra step. So my strong recommendation is to leave it as a reduced improper fraction.
I'm too lazy
But that, of
to do
course, is
extra
you.
Steps.
Isn't it just -1?
Yes, it is. That one's easy. Yeah. Yeah. Just the more steps you do, the more likely to accidentally get something wrong. That's the yeah. No, that one is pretty easy. I agree. Excuse me.
Wait, how'd you get it down to just 19? Is that the part you kind of skipped over?
Yeah, so when you do, you end up with the square. Hold on. You go in the garbage. Thank you. Okay. You end up with a square root of, hello? Oh, there it goes. Of 361. And then if you punch that, I don't expect you to know square root of 361 off the top of your head. That would be surprising. But if you punch that in your calculator, you discover that square root of 361 is 19.
So it is. You are correct.
And so that's, yes, that was a space where I skipped that. Any other questions on this problem? I don't want to rush anybody, but
No.
how we doing, ladies?
It's one of those ones where I made a mistake, but I know what the mistake was, so it's fine.
Okay, well, so my guess is the real mistake was going too quickly. So
I
probably
know I
slow
have the
down.
wrong quadratic formula because I can't
Oh.
maintain those handwriting.
Oh, okay, well. Negative b plus or minus square root of b squared all minus 4ac all over 2a.
I didn't have the 4. That was my big thing. So I had a very...
Any questions, girls? Are we doing good on this one? We understand?
Well, yeah, I just put it in.
25 divided by 4.
So, okay, so this last bit, remember that you're splitting it into negative 25 plus 19 and negative 25 minus 19. So, over 4, right? And then, so you're not doing 25 divided by 4, you're doing negative 6 divided by 4, which is where the negative 3 halves comes from. And you're doing, what is that, negative 44? Negative 44 over 4, which is where the negative 11 comes from. Does that answer?
No. That raises more confusing questions. I'm confused.
Where are you confused, buddy?
What you just did.
I split this plus or minus into its two constituent bits.
Yeah. I'm glad I guessed.
That would bug me. Couldn't do it.
What, leaving
Her screen is like this.
What?
I would have her thing is like this, and that would probably I would have to fix it. Like I say, I would have to fix it. I'm maybe not quite as bad as Emma, but I do have to fix things. I already said I did, like when I'm in the bookstore, if there's a book like pushed off center on one of those tables, I fix it on the way as I walk past.
Fill up the entire screen.
Not probably quite as bad, but I do fix stuff like that. I absolutely do.
What if the entire mystery section was backwards, so you could only see the pages?
If that was all true, then I don't know that I would take the time to fix an entire section. But if one book was that way, I would probably change it. I probably would.
That reminds me.
section.
Okay.
Of the time JC and I were at Barnes & Noble, we saw
This
just power
mystery is like the title.
with an
So
arm
you
full
go
of
mystery
books
section.
on the wall.
You don't know.
Power walk. You said who? You said what was walking? What now?
You were power walking through Barnes and Noble.
With an arm full of books.
Yeah.
It's possible.
You should make it felt the entire.
I do like to go to Barnes and Nobles. Yes. I don't know who said that. I think, was that you, Amy?
No, it was definitely me.
What? Lies.
The fraction first.
That's fine. That's totally fine.
That's that too.
I know, I heard you say that, and I was like, I don't remember what the answer is.
Okay, so we're going to do example number 2.
No, you cannot. Has to be last. Unless they're both.
Example number 2, we're also going to solve this with the quadratic formula, and the problem is x squared.
Is this guided practice or?
Example. Examples have circles. Guided practice have GPs. That's how I've been doing it. But you're always welcome to ask. Doesn't offend me. I'd rather you ask than like some of my other classes that sit and try to talk and whatever else. One in particular.
Taylor.
No.
So, dang, Taylor.
Kaylee does every once in a while use her phone, but the only time she ever does use her phone is when she has taken a picture of the problems and she's using it to to do her work. So every once in a while I'll give her a hard time about it, but I don't like yell at her about it.
You should give her a hard time
That's
today.
what I do, because I don't want to look
To give people a hard time about.
Yeah, that's totally fine.
pages don't stay
You
open.
give, just like everything, you can give somebody a hard time about.
Yeah.
You specifically
I-
give somebody a hard time.
Well, that's probably true.
What is that?
Machine.
What is that?
It was gonna be an 8, but it like stopped in the middle like 3 times, and so it ended up being some sort of strange backwards S.
So it's like a 5.
Okay.
Wait, what?
It's not being an eraser.
Okay. And I'm gonna leave that just because.
No, no, no.
Get the big.
What's worse is when someone doesn't have an actual paper. When they are erasing, oh, it's the worst. And then they keep writing over top of it.
So much eraser trying to get rid of.
Okay, so let's solve this one. We're going to walk through this one together. The beginning's not much different than anything else we've done so far in the problem or the guided practice or whatever else, right? So A in this problem is what? A in this problem is what? 1. B in this problem?
8.
C is 16, right? Magical unicorns. So now when we're plugging in the formula, what is the formula, boys and girls? And by boys and girls, I mean Nate. What's the formula?
The formula is b times the square root of b squared.
Hold on. We're close, but not quite. Where do we start?
The opposite of B.
Opposite of B. If you don't have this down, I would write it down. Plus or minus. And now what, Nate?
The square root of b squared plus 4a.
We're close. Minus 4AC.
4AC.
All
All over 2A.
Why do you have to say the opposite of?
because it's better
Because it
than
sounds
saying
Wait,
negative.
Cooler
is
that
that
way?
negative thing?
My
No,
AC
you
is
should just
16.
say x equals.
You can if you
What?
want to.
Chainmail plus shield.
She was wondering why we said the opposite.
Because I guess grew up saying the negative B, but then in college or somewhere at some point somebody started making a point of saying the opposite of B, which I get it from a teaching standpoint because then it's less confusing if the B is already negative, that you're going to end up with a positive number, and so that's why it's true. Negative is still a positive. But so I tend to say both. Sorry that it apparently bothers you.
No, it makes sense.
Oh, good.
Definitely bothers her.
It makes sense. That's why I asked the question, goober. I'm gonna laugh when I am walking by y'all at some random point in your life, and I hear you say to someone else, goober.
I'll call Bryce that now.
Gonna call Bryce that now.
Oh, I will. Bryce deserves
So we're going to put 8 right here. We're going to put 8 right here. We're going to put 1 and 16. And we're going to put 1, right? So then we have negative 8 plus or minus the square root of 64 minus 64. Is that right? 4 times 1 times 16. Does that sound right to everybody?
Yes.
Yep, sure.
I just checked.
Over 2.
Wait a second.
64, yes.
Yeah, hence the example.
How dare you?
Hence the example. Okay? That's why we're doing it.
You mean to us.
What's that?
Extremely. Wait, this could be.
What has he done? No.
This will be easy.
Wait.
Wait for it.
No. What have you done?
Negative 8 plus or minus 64 minus 64 is 0. Yes.
That's what.
But that we can't have that.
We can. 0 times 0 is 0. So square root of 0 is 0.
Square root of 0.
You absolutely can have square root of 0. We even know how to have square root of negative something now.
Yep.
That used to be impossible. Look at y'all. Y'all are proving the impossible possible in Algebra 2.
No. That's,
At least some examples of it. The square root of 0 is 0. So we end up with negative 8 plus or minus 0 over 2. And it doesn't matter at this point whether we add or we subtract 0, right? It's the same thing. So this ends up being negative 8 over 2, which means that our final answer is negative 4 and only negative 4. Now, wait for what, girl?
We did it.
Now, I think we've touched on this before, but let's touch on it again. Let me open Desmos. And let's see if we can see what's happening. Did you say, huh? Okay, so I'm going to plug in our previous example into Desmos. Okay, so our previous example, if we put a y instead of a 0, right, it would, for example 1, it would be y equals x squared x. Good Lord. It's going to be faster to take the minute to flip this around. Give me half a second. Than it is to be to type on that stupid calculator. Yeah, it was exactly. Look at that. Bueno. Y equals x squared. Yeah, that should have been obvious before. Minus 10x
Really?
minus 11.
I like how it's just being fun.
Oops. So this is the one we did a minute ago, right? This was example 1. You follow? Yes, no, maybe?
Yeah.
What did we get when we solved for x on example 1?
11 and negative 1.
11 and negative 1.5, right?
No.
Or no, that was on the 11 and negative 1, yeah. So if we zoom in here,
This the guy.
then we see that where this crosses as at 11 and at negative 1.
So is the one.
So what we are finding, and we'll get to this in another unit here in a minute, or not in a minute, but in this chapter, that what we're finding are the zeros, right? So the example 1 had 2 zeros, which is what we expect a lot of times. There are 3 options. We have now seen 2 of them. We're going to see a third today. We've seen one option where you have 2 zeros. That's the maximum you can ever have. This parabola can never cross it more than twice, right? Because it doesn't have any other shapes. It just looks like this. So he's only got 2 little bits. So we just found one where we found 1 0.
Which is where like the point is.
So let's see what that looks like. Let's graph that guy. So if we graph example 2, it would be y equals x x at square x squared plus 8x plus 16, right? What did we get when we solved that one?
0.
We didn't get 0. That's not true. What did we get? We got a 0, but we got, what number did we get?
4.
-4. So if we look and see where where it kisses the x-axis, it's at -4. So when we get 1 0, that's what's happening. We're going to see one here in a minute where we get no zeros, no real zeros. It's just above the x-axis. Making sense to everybody? It's important that we take a minute to look at these picture bits along with the just abstracted algebra bits so we can understand what's happening. We can put all these pieces together. Okay, I'm not hearing any like gasps or astonishments or anything like that, so I think we're good to move to the next thing. Okay. All right. If we're lucky, we're going to squeeze in 2 more examples. Sound great to everybody? No. Great. TTFN. Ta-ta for now. The wonderful thing about Tigger is that Tigger's the only
Nothing
one.
whatsoever.
There's a lot of good things about it. Don't be.
Anybody in here actually read any Milne, any Winnie their Pooh?
Yeah, I have.
Well, good. I figured 1 or 2 of y'all probably had, or 3 or so. I have 2. They're quite good. Okay. So example 3.
Why do I feel like examples should start with an X?
Sounds right. Even if it's wrong, it sounds right. Just like espresso. It makes sense when people pronounce it espresso, even though that's wrong.
Just espresso.
Which is why people spell it wrong. And it's, what am I writing? That's not a quadratic. I'm struggling with this stupid pen.
It's easier to pronounce it if you do it with an accent. Espresso.
That makes sense.
Do it with the Google Translate accent.
Do it with the Google Translate accent. That's kind of funny.
The Google Translate accent's easy to do.
Google Translate is terrible.
Just
How is Google Translate terrible?
What
Let's
is that?
translate correctly.
Well,
It does,
has
though.
some issues with grammar.
It translates precisely, which isn't always how things are spoken.
It has
You,
issues
I
with
tried to
grammar.
find some this Polish guy. You put in Google Translate, and you're like,
From this Polish guy. I've never really tried to translate anything from or to Polish, and I don't know any Polish, so I can't speak to that. But I know in Spanish it's all right. It's not perfect, but it's all right.
Why is there a sideways Croatia?
It is a 7. I don't know why it went wacko, but it did. Okay, so A in this case is 2,
Just looked like
B is 6, C is -7, right? So our formula is the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. Right? Right. So then we're going to go ahead and plug in our numbers. That's funny. But I can't deal with it right now. So we're going to plug in 6 right here, 6 right here, a 2 right here, a -7 right here, and a 2 right there.
Cool.
Right? Right. Now, so then we're going to walk through and find our answers. Here we go. -6 plus or minus square root of 36. Plus 56. That's what I get in my head, but I could be wrong. Over 4. Which means we end up with negative 6 plus or minus the square root of 80 plus 12 would be 92. Does that sound right? Sounds right to me. Over 4. Now, everybody freeze.
I've gotta like catch up to that point.
When you stick the square root of 92 in your calculator, what do we discover about the square root of 92? It's, in other words, it's, what's the word for that?
Unsolvable.
Lies. It is solvable, just not with a rational number. Therefore, it is irrational. Thank you.
I like my answer better.
Okay. So, this answer gives us an irrational root. So now, instead of getting a decimal equivalent, we want to just simplify this ugly number. So we don't need to simplify that radical, right? So, is there a perfect square that goes into 92? Well, what are your perfect squares? Let's list a few.
1, 2, 3,
1 is not, 2 isn't either.
4,
4 is.
6,
4, then 9,
Yes.
16, and then
That's plenty to start with.
56.
Do any of those go into 92? You can check it on your calculator, right?
It's true.
What? Is that enough?
Yeah.
So do any of those perfect squares go into 92?
4 does.
4 does. So we can split this into the square root of 4 times the square root of what?
23.
23.
Of which I do not believe there's a square root of 4.
There's not. In fact, there's nothing that goes into it except 23 and 1 because 23 is a prime number. So this square root of 92 simplifies into 2 times the square root of 23. Right? We following? We caught up more or less? Okay. So we can write this problem as negative 6 plus or minus 2 times the square root of 23 all over 4. The last thing we need to look at is, does this reduce?
Yes.
It does reduce because we can divide every single term by 2.
It's not 23.
It is 23.
You can't.
Or you can't divide 23.
That's true, but we're leaving the 23. It's going to sit there. The term is this whole shagoigle. Right? We're going to divide that by 2. And we're going to divide... Pen? I will throw you through the wall.
4 was into 92.
that's
Yeah, that's not gonna.
Productive? I know. It won't even make me feel better. It'll just probably make me more irritated, so it's a bad idea.
Okay.
Okay? So, when we reduce this and divide everything by 2, we end up with negative 3 plus or minus the square root of 23 over 2. And that's as simple as it'll get. Right there. So, back to my thought idea here. For this particular problem, is it going to cross the x-axis once, twice, or not at all?
not at all.
That's a lie. Irrational numbers are numbers. So do we have, does this, if I was to get a decimal equivalent, would I get one of them, two of them, or no real ones? Two of them. I would get two of them if I was to get decimal equivalent. In fact, if we punch this in, we can kind of prove it to ourselves. Y equals, what is it?
2x squared plus
2, nope, lies. X squared
plus 6x
plus 6x
minus 7.
minus 7. That takes so long to punch in on that thing. So we can see that it does, in fact, cross. It crosses at,
A really weird number.
yeah, some really ugly number, which we would get is if we punched that square root of 23 in our calculator and then added it or subtracted it.
Actually, the square root of 23 is. Oh, wait, no, that's.
Yeah, the square root of 23 is whatever that is.
4.7958.
Yeah, so then, but then to finish the answer, we have to do negative 3 plus that, negative 3 minus that, and then divide each one of those by 2. And so we get two answers there. Okay, so let's do, I think we can squeeze in one more example, which is good, because that's what I wanted to do. And we will squeeze in the discriminant next time and the next lesson probably. Because discriminant is just a piece of the quadratic formula. Okay. So what is this, example 4? X squared minus 6x. We're going to kind of cheat, make it faster by putting plus 10 equals 0. So when we plug this into the quadratic formula, what am I going to put right here?
1. Wait, no. Say negatives.
Negative 6, you were right. Square root of negative 6 squared minus 4 times, what's going to go right here?
1.
And then right here, 10. And then all over 2 times, what's going to go right here? 1. Okay. So now, let's see, when we walk this down, negative 6, or the opposite of negative 6 is positive 6, right? Plus or minus, square root of negative 6 squared is what? What's 6 times 6, y'all?
36.
Thank you. Minus 4 times 1 times 10 is what?
Negative 40.
Negative 40.
All over 2.
All over 2.
Or 2, everybody is all over it.
So then
66.
we end up with 6 plus or minus the square root of, what's 36 minus 40?
6 minus. Negative 4.
Negative 4. All over 2, right? Now, a negative under a square root, what's going to happen with that?
I.
We're going to get an I, which means we don't have any real solutions, only a couple of complex ones, or imaginary ones if you prefer that term. I don't, but if you do, there it is. Okay, so this would equal
Imagine that.
6 plus or minus 2i. How did I get 2i? Where did that come from?
Because you
I imagine you
the
got
negative from underneath the.
Yeah. The
I didn't really understand you.
Square root of 4.
The square root of 4 is 2, and the square root of negative 1 is I. So 2I, right? Now we can reduce that by dividing everything by 2, correct?
So 3 plus or minus I.
3 plus or minus I is correct. So this graph, if I was to take our remaining 2 minutes and plug that into Desmos, how many times is this graph going to cross the x-axis? 0 times. There are no real roots. It's going to be up above somewhere, right?
That
Or
amount of times.
no.
You can only do it.
There is one type of function that would touch it an infinite amount of times, and that would be y equals 0.
Oh.
Because it's just,
I'd like to see that on Desmos.
It just turned the x-axis red or something, probably. Does it make sense, this problem? Good. Sign some homework. Didn't let y'all leave.
Maybe not.
I think some practice would be a good idea. That's my kind of theory on that. I can't prove that necessarily, but I can definitely evidence it.
Sure.
Page
0.
your homework assignment is going to be pretty short.
That's okay. I don't think.
I am going to give you one that I suspect you may have a question on, which is okay. But I'm not going to give you any of the ones where you have to use the discriminant because we haven't talked about it yet. But it's easy, so when we do talk about it, you'll be fine. Numbers.
I think we should all be pretty good with discriminating.
That's not what that word means. Although it kind of does, actually. I never really thought about the connection of the etymology of that word. 14 through 20, evens.
Well, that is very short. Impressive.
Goodbye, kids.
Goodbye.
Hope your weekend's great.